so for some of the problems today, we're actually going to be drawing some pictures, and you can be as fancy in your pictures if you're an art lover, or you can be as basic in your pictures if you're not so much of an art lover. It doesn't really matter, but we're going to be talking about angles of elevation and angles of depression. And so what you mostly need to remember when it comes to an angle of elevation is, if you were to look forward and the degree of that it would take for your head to look up at something higher than you, that would be angle of elevation, okay? If you were to look forward and the degree that it would take for you to look down at something lower than you, that would be your angle of depression, okay? So if you look at here, we've got our horizon line to look up at the plane, that makes that elevation. If we're standing on a cliff to look down at the water below the cliff, that would be our angle of depression. So suppose you are looking up at an airplane, the angle formed by the horizontal line in your line of sight is called the angle of depression, or sorry, angle of elevation. And suppose you're standing on a cliff looking down at the river below, the line that stretches horizontal from your view on the cliff, your angle of sight to the river below forms an angle of depression. With the river below or whatever. Okay, you can use, then once we set up these pictures, we'll be able to use our knowledge of trig ratios to actually solve problems. So for example, in 1, we have a lifeguard looking down at a swimmer in a swimming pool. The line of sight forms a 55-degree angle. So looking down, that would be an angle of depression with the horizontal line. And you are 10 feet up in your seat, so you're 10 feet above. How far is the swimmer from the base of the lifeguard stand? So what we're looking for is how far the swimmer is from this base. That would translate up to that height in our right triangle. So those X's would be the same length. Was it there?
Nothing in the printing.
Really?
Yeah.
Okay. I'll have to check that then. All right. So when we are trying to solve for X, we're going to be looking at this triangle just like a regular triangle, like the ones we've done in the past. With the angle I know, I have the opposite side and the adjacent side. The hypotenuse is unknown. So I have to use the trig function that deals with opposite and adjacent. So this is the tangent of 55 is equal to the opposite over the adjacent. How do I solve a problem like this? You guys remember what we do? What's the move mathematically? Yeah.
Do you multiply it?
I do not multiply. Yep, I'm going to flip the x in the tangent, so x is equal to 10 divided by the tangent of 55. And then that's what I'll plug in my calculator. So it looks like we have a length of about 7 feet. Final answer. So let's take a look at our picture below and let's start labeling these. if I am in this, I don't know if that's supposed to be a bird or a plane. I think that's a bird. If I'm the bird looking at the person in the balloon, is that an angle of elevation or an angle of depression? I got two answers. Definitely depression. Because looking down. Okay, if I am in the balloon and looking up at the bird, what is that? Elevation. If I am in the balloon looking down at the base of this mountain, what do I have? Depression. Not really. It makes me so sad to see the base of that. And if I am an ant at the base of the mountain looking up at the balloon, what am I? Elevation. You got it. They can't. Oh, really? Then I'm not an ant. I'm a bunny. I'm a bunny on the bottom. Bunnies can look up and down, right?
Yes.
Okay, good. That is something I did not know about ants. So let's go ahead and list these. Give it a try. I'll let you guys try on your own. Just under angles of depression, list the angle numbers that fall into that category. Under angles of elevation, list the angle numbers that fall into that category. I'll give you a moment to do that, and then we'll share. All right, depression. Which ones are depression? Angle 1 and angle 3, elevation. Angle 2 and angle 4. Great. Okay, so now let's do some solving. No different from what we were doing before. In these problems, we have the picture drawn for us, but in some of them, we're going to have to actually draw the picture. So in this problem, I have the picture drawn from us. It looks like we've got, I don't know what that's supposed to be, a guy up on a tightrope or a guy up on a, oh, he's going skiing. He's snowboarding, yes. And he has an angle of depression to the little chalet at the base. He knows his straight line of sight is 600 feet. How far is he from the chalet? So let's label what we have. Across from the angle is the opposite. I know the hypotenuse. I know the adjacent. What's the only trig function available to me for this problem? Cosine, great. So this is the cosine of 51 equals the adjacent over the hypotenuse. How do I solve? Yep, flip-flop, yep. So x would be 600 divided by the cosine of 51. Go ahead and plug that in your calculator. I'll let you guys do that and then give me a shout out for an answer when you get it. 153. 953. Does anybody else agree with that? 953, we've got a concurrence? Okay. 953 feet. Up next, we've got this boat and an airplane. And somebody in the boat is looking up at the airplane at an angle of elevation of 25 degrees. If we know that the boat is 75 yards horizontal distance, how high is the airplane? So again, we'll set up our stuff. I gave you my one that I had. Opposite, I know the hypotenuse. Adjacent, what's the trig function that I can use on this one? Tangent. Tangent of 25 equals the opposite over the adjacent. How do I solve this one? Multiply. I do 75 times the tangent of 25 to get my x. Again, I'll let you guys do the math and you can tell me what you get. Yes. 34. 34 yards. Make sure you put the right label on that. Okay, so now they're going to put an actual story to the problem. This is what you're going to have to duplicate on occasion. You're going to have to take the story and try and draw the picture. In fact, we'll do one of those before we let ourselves go. A fire ranger stands at an observation window 70 feet above the ground. She sees a fire in the distance. She takes a reading of the angle of depression and finds it to be 24 degrees. To the nearest tenth of a foot, how far away from the base of the tower is the fire? Where should my X go?
Below.
Below.
Yeah.
Good.
Yeah.
Now, one thing that is a fact is that the angle of depression that it takes for the fire ranger to look down at the fire is equivalent to the angle of elevation that it takes for somebody at the fire to look up at the top of the tower. So in some instances, if I know the angle of depression, but my drawing needs the angle of elevation, I can just translate that angle down there. So it'll take the same degree to look down as it will to look up. And then we can set up this problem: opposite, hypotenuse, adjacent, which trig function again?
Tangent.
Tangent. Tangent of 24 is equal to the opposite over the adjacent. How do I solve this one? Divide. X equals 70 divided by the tangent of 24. I'll let you guys do the honors.
$157.
157 is what I heard. Feet, because that's what they measured in. Okay, so let's do our own drawing. In fact, I'm going to let you try. Read the picture. I'm going to give you a little bit of time. Read the scenario. See if you can make that drawing, and then we'll check and see how you did. If you don't trust your drawing skills, I suggest that you use pencil to try it. Okay, so let's see how we did. Suppose you're looking up at the top of a building. The angle of elevation from your eyes to the top of the building is 65 degrees. You are standing 80 feet from the building, and your eyes are 5 feet above the ground. How tall is the building to the nearest foot? So here I am. Look at my artistic abilities. Yeah? Okay. Here's the building that I'm looking at. I might even put windows in my building. And a door. There we go. There's my building. Okay? And it says for me to look up to the top of the building. Remember, here's my horizontal. That's 65 degrees. That's my angle of elevation for me to look up to the top of the building. Right here, if I look straight at the building, I would look at a spot 5 feet above the bottom. Does that make sense? Because I'm 5 feet tall, so that's straight distance. So when I find my height of the building from my eyesight, it is going to be 5 feet off. So I'll have to add that to that in the end.
So they're out of paper.
Okay.
But she says that it's going to be like a 15 to 20 minute wait.
Okay, that's fine. So we do 80 down on the bottom. We're looking for X. We'll go opposite, adjacent, hypotenuse. Looks like tangent again. Tangent of 65 is equal to the opposite over the adjacent. How do I solve this one? Multiply. I'll let you guys do the solving. What'd you get? 72 feet. That's this distance. I'll add the 5 to it for that to take care of my height. Does anybody agree with 72?
No.
Oh,
I rounded up. It's 171.
Oh, 172.
You just said 72.
Hey, that's okay. We're not gonna yell at each other. 172 plus 5. Where'd the 5 come from again? Yep, that 5 feet that we have at the bottom. What's the height of the building? 177 feet. So that is it for these notes. We're done. Do you guys have another page?
No.
No, I didn't think so, because I didn't, so. Okay, we're done for these notes. And the bonus news is your homework didn't print. So, you have no homework. We're done for the day. And you guys, again, I'm